Hurricanes are among the most destructive forces in nature. In 2004, they caused nearly $19 billion of damage in Florida alone. Hurricanes can pack winds well over 100 miles per hour and rip property to shreds. If that were not enough, heavy rains and surging seas bring dangerous floods. Planning evacuations depends on knowing where and when these whirlwinds will make landfall. Scientists at NASA's Goddard Space Flight Center are researching ways to make hurricane forecasts even better than they are today. Chief meteorologist Bob Atlas started forecasting with a toy weather kit when he was 12 years old.
A year later, I had a very unique opportunity, and I became an apprentice weather forecaster for the U.S. Weather Bureau, which is now the National Weather Service. And during that whole time, I learned meteorology and I made weather forecasts alongside the professional forecasters. And this gave me a tremendous feeling for what is required from research and what new knowledge is really needed to improve weather forecasting. And this has benefited me through my entire research career.
Hi, Rusty. Do you have the latest on Carl?
Yes, hi.
Atlas leads a team of meteorologists, computer scientists, and computer graphics experts. To make hurricane forecasts, they use a computer simulation tool called the Finite Volume General Circulation Model, or FVGCM for short.
The FVGCM breaks the atmosphere down into blocks of latitudes and longitudes, which we call grid cells. And we lay these blocks out over the surface of the globe and stack them on top of each other, from the surface to the top of the atmosphere, about 55 kilometers above the surface. Within each of these blocks, we solve a set of basic mathematical and physical equations which govern the dynamics and physics of the atmosphere.
By putting all the blocks together, the model can follow weather around the world. NASA recently shrank its model blocks down to 25 kilometers. Small blocks mean high resolution. And in 2004, the FVGCM had the best resolution of any global model making real-time weather forecasts.
Theoretically, you could run a model at any resolution provided you have enough computer time. But when you're interested in real time, you want the forecast to come before the event that you're trying to predict.
Powering these forecasts is a NASA supercomputer named Columbia. This machine can crunch over 50 trillion calculations per second. Using a fraction of Columbia, the FVGCM can make a 5 or 10-day forecast in less than an hour.
We began running our experiments in early August of 2004, right as the hurricane season began to heat up last year. And the forecasts continued throughout the entire hurricane season and even into the fall and winter.
FVGCM forecasts ran at noon and midnight every day. The 2004 Atlantic hurricane season kept the model very busy.
In 2004, we had 15 named storms, 9 became hurricanes, and 6 became major hurricanes, well above the average for a particular year. In addition, in 2004, we had a blocking high-pressure system in the North Atlantic that prevented the hurricanes from moving northward early in their life cycle. As a result, these hurricanes were steered towards the United States mainland, and in particular, more often than not, towards the state of Florida.
Charlie, Francis, Ivan, Jean. These hurricanes slammed Florida during August and September. Despite the challenges, the FVGCM saw dramatic improvements in its ability to forecast hurricanes.
The fundamental barrier we have crossed by going at such high resolution is that for the first time in a global model we started to see realistic hurricanes with realistic intensity and realistic structure.
One of those was Hurricane Ivan, where 5 days in advance we forecast Ivan to intensify from a Category 1 to a Category 4 hurricane, then to weaken to Category 3 before landfall. And we forecast the position of the landfall 5 days in advance with an error of only 46 kilometers, which is about a tenth of what might be typical in a 5-day forecast of hurricane landfall.
In the real world, Hurricane Ivan did intensify from Category 1, but up to Category 5. Ivan then weakened to Category 3 before landfall, very close to the model's prediction.
With Hurricane Jeanne, also 5 days in advance, we gave an extremely accurate prediction of the track. We showed the landfall in Florida with only a 2-kilometer error in the position, and then correctly forecast the track across central Florida after the landfall occurred.
Ivan and Jeanne formed off the coast of Africa and grew as they crossed the Atlantic. The FVGCM had problems with hurricanes that behaved differently.
The worst case was actually the case of Gaston, which formed very close to land and made landfall almost immediately, and that was a case in which our model did not perform so well.
Official hurricane forecasts for the eastern United States come from NOAA's National Hurricane Center in Miami, Florida.
We can see the enormous improvement that the National Hurricane Center has produced by thinking on what happened in the year 1900 when the entire city of Galveston in Texas was completely destroyed without any possible warning. This has not been happening for a long time because the National Hurricane Center has this capability of predicting hurricanes well before landfall, so there is no such thing like a city be essentially hit by a hurricane unexpected in the middle of the night.
NOAA's National Hurricane Center does an outstanding job in forecasting hurricanes and in warning the public. NASA is interested in working with NOAA to help them to improve their forecasts beyond the limits of current forecasting skill. This can come about through the use of both the FVGCM and through better use of satellite observations.
For example, the FVGCM is now part of Florida State University's Super Ensemble model, which blends forecasts from several atmosphere models.
The Super Ensemble combines these track and intensity forecasts to produce an optimal forecast of a hurricane's path and potential intensities. These forecasts will be sent directly to the National Hurricane Center in Florida for forecasters to use as guidance in their prediction of a hurricane's path and movements.
The stakes with hurricane forecasting are high. Currently, a significant portion of residents ignores evacuation orders, putting their lives at risk.
If we have more accurate forecasts and less uncertainty in the areas in which the hurricanes will make landfall and move, then these residents will be more likely to follow the watches and the warnings and the evacuations that are ordered. And this will result in a further saving of life beyond that of what we have today.